Hello students. In this video I am going to discuss with you that what are thermodynamic state functions and why work and heat are not the state functions. So let's start by looking at what are the state functions. A state function is a function which has the same value when it is measured through different pathways or different routes from initial and a final points. Let's suppose we have an initial point A and B and the final point B, and we want to measure something from A to B. So if this is the path A and this is the path B, and if we have some function, if this function comes out to be same and it has the same value when measured through this path, blue line, and to this path, then it will be a state function. So basically the state function is not depending upon the kind of path that we are following. It is only depending upon the initial state and the final state of the system. So there are many thermodynamic functions that are state functions like volume, enthalpy, temperature, and pressure. It is to be noted that the state function does depend on the initial and the final state. It just does not depend on the path that we are following to measure any of these parameters. Now let's see an example how the enthalpy of reaction, which is denoted by delta HR, is not a state function. So let's consider an example of the oxidation of glucose, where glucose reacts with oxygen to form carbon dioxide and water. This is a very common reaction that is given in the books, and it's occurring in the human body, in every cell of the human body to produce energy. So basically the enthalpy of reaction for this reaction is negative, and it comes out to be minus 2816 kilojoule. So we can measure this enthalpy of reaction by a method which is called as heat of formation method. And what happens in this method, we measure the heat of formation of glucose, which is a positive value. As you can see, this arrow, purple arrow going up, which shows the positive energy. So the heat of formation of the glucose and oxygen is determined, and then the heat of formation of the products is determined, that is the carbon dioxide. This one you can see here, the energy is going down because the heat of formation for carbon dioxide is basically negative. And then the heat of formation of the water is determined, and again you can see this green arrow downward, it shows the negative energy of the formation of water. So once we add the heat of formation of the products, the carbon dioxide and water, and we take the heat of formation of the reactants, and we subtract the two values, the heat of formation of product is subtracted from the heat of formation of the reactants, then it gives us the value of the enthalpy of reaction, which is this value minus 2816 kilojoule per mole. So this is the process to determine the enthalpy of reaction for this particular reaction and many other reactions. But we can also measure this enthalpy of reaction by other methods. Like one of the method is the bond enthalpies method. So what is done in this method? We calculate the sum of the bond enthalpies of the products, and then we calculate the sum of the bond enthalpies of the reactants, and we take the difference of the two values, which give us the enthalpy of reaction. Now if you do this calculation by finding out the values of the bond enthalpies, or using the internet, you can find out the bond enthalpies from the internet, and you do this calculation, you will find that the enthalpy of reaction will come out to be the same, that is minus 2816 kilojoule per mole. So basically enthalpy of reaction is a state function because it's not depending upon the path that we are taking to find out the value of enthalpy of reaction. By the two different methods, its value is coming out to be the same. So why work and heat are not state functions? Work and heat are not state function because they depend on the process or the path that is followed. Now let us see with the example that how work and heat are not state function. Suppose I want to go from the ground floor to the 6th floor of a building, and I have two routes. The first route is through elevator. I can use the elevator to go from the ground floor to the 6th floor. and the second route is through the stairs. I can use the stairs to reach the 6th floor. So what do you think, that the work done in using the two paths will be the same or not? So will the work done, which is basically W is equal to F dot D, will be the same or not? The work done will be different because it will be depending upon the path followed. The energy and the distance is different while I'm going through the stairs or using the elevator. So definitely the amount of work done that will be done by me using the stairs will be different compared to the work done by me when I'm using the elevator. So it's depending on the path that I'm following. So it means work is not a state function. It is depending on the path that we are following. So similarly, heat is not a state function either. So heat, what is heat basically? It's the energy which is transferred from one system to the surroundings. And definitely, if we are transferring the heat from one system to another system, it will depend on the process by which the heat is transferred or the path that is taken to transfer the heat. And the amount of the heat that is transferred, it will be depending upon the path or the process. Let's suppose generally if we have some heated water and I want to transfer this heat by some ways to another point, and if I take one process or path and I transfer the heat by this, let's suppose brown path to this system, and then I have another path that is represented by this pink line, and the heat is being transferred to this point again, then you will see that the amount of the heat transfer will be different because the path is different and the heat losses will be different, and therefore the amount of heat transfer is different and it's depending on the path. So heat is also not a state function. There are many other functions, thermodynamic functions, that are state functions like number of moles, the mass, the pressure, and the volume. And I will give the examples of how these thermodynamic parameters and other parameters are not path dependent in the other video. So thank you for watching. Please subscribe my channel. Thank you.